Okay, so now we're busy with video F, the sixth video of exercise 5.5 on page 127. We're now looking at number 3. Okay, so in number 3 we are given two equations. Okay, one being I ask you to sketch the graph of y equals x plus 3 squared minus 4 and y is equal to negative 2x minus 7. Okay, so the first graph is your y, if we're going to consider y is equal to x plus 3 all squared, then what I'm going to do is I'm going to say, firstly it's positive, so the graph is smiling. Secondly, x-intercept. X-intercept we let y equal to 0. So 0 is equal to x plus 3 all squared minus 4. Okay? Take 4 over, so it becomes x plus 3 all squared. The square root thereof is going to be plus minus 4, which is plus minus 2, as the square root of 4 is 2, x plus 3. We take a 3 over, so x is equal to minus 3 plus minus 2. Okay, so we got x is equal to negative 5, or x is equal to negative 1. Alright. The next step is our y-intercept. What do you do for y-intercept? Let x equal to 0. So y is equal to x plus 3 squared minus 4. So 3 squared is 9 minus 4 is 5. So we got 9 and 5. 9 squared minus 4 is going to give you 5. The next step is our turning point. So what do we do for a turning point? We can read it off from here. As you can see, it's in the form of y is equal to a plus p squared minus plus q. So it's going to be negative 3 and negative 4. That's your coordinates of your turning point. Okay. So that is enough information to draw the graph. So yeah. So the graph is smiling. Here's an x-intercept at negative 1 and negative 5. Okay. Here is an axis of symmetry at x equal to minus 3. That is midway between the two x-intercepts, if they are. So that's going to be negative 3. And our negative 3 is turning at negative 4. So negative 3, negative 4. Got your y-intercept at negative. At 5, so it's fairly high there. So the graph is going to come through there. Okay. So on the other hand, let's look at the straight line graph. So this one here, I'll do it in green on the side. So we have our x-intercept. What do you do for x-intercept? Do it here. X-intercept, we let y equal to 0. So we got 0 equals negative 2x minus 7. So 2x is equal to negative 7, x is equal to negative 3.5. Okay, or negative 7 over 2. Now if this is negative 3 here, negative 3.5 is approximately here. Okay, so it's going to cut that. Then for our y-intercept, what do you do for y-intercept? Let x equal to 0. Okay. So we have y is equal to negative 2 times 0 minus 7, which is negative 7. So if that is negative 4, negative 7 is fairly low. So there we go. So it's going to go through negative 3.5 and it's going to go through negative 7. And there we go. Okay. So now coming back to the second part of the question, the B part, it says, calculate the point of intersections of the two graphs. Calculate the points of intersection. So the points of intersection they're referring to is that one there and this one here. So when we do the calculation, there will be 2 points of intersection. How do you work out the points of intersection? We set the two graphs equal to each other, okay, as they are equal at those points. So the one equation is x plus 3 squared minus 4, and the other one is going to be negative 2x minus 7. Okay, so it's going to be x squared plus 6x plus 9 minus 4 equals negative 2x minus 7. Okay, so it's going to be x squared plus 8x. So it's 16 minus 4 is going to give you 12 equals 0. So trinomial, so x and x, 6 and 2, plus and plus. So if we solve for x is equal to negative 6 or x equal to negative 2. Okay, so what do we do with this? We sub it back. So we then either substitute in a straight line or into the parabolas equation. So y is equal to negative 2 into negative 6 minus 7. So it's going to be 12 minus 7 is 5. So this one point is negative 6 and 5. Okay. The other one we have y is equal to negative 2 minus 7. So it's going to be positive 4 minus 7 is negative 3. So this point is going to be negative 2 and negative 3. Okay. So the point negative 6 and 5 lies there. Whilst this point here is going to be negative 2 and negative 3. Sorry, negative 2 and negative 3. So these are points of intersection. Okay. What if they had asked you, where is, let's use another color. Where on the graph is the parabola, which is x plus 3 squared minus 4 greater than or equal to negative 2x minus 7. Okay, if the parabola was called f and the straight line was called g, then I would have just said f of x is greater than or equal to g of x. That means the same thing. So if we look at this here, f of x is below here. Can you see that? It's smaller than. Even on this side, f of x is on top. You see that? The side here, f of x is on top. So in other words, we have to say x is less than negative 6 and equal to, okay, or on this part here, x has to be greater or equal to negative 2. Okay. Okay, now we're looking at number 4. Number 4a says sketch the graphs of y equals f of x equals negative 2x squared x minus 3 whole squared plus 2 and g of x equal to 4x minus 10. So let's go with f of x first. So the graph is frowning as it's negative there. Second is our x-intercept. We let y equal to 0. So you got 0 is equal to negative 2 into x minus 3 squared plus 2. Take it over, becomes 2 into x minus 3 squared equals 2. So x minus 3 squared is equal to 1. Square root thereof, x is equal to plus minus 1. So x is equal to 3 plus minus 1. So x is equal to 4 or x equal to 2. Y-intercept. What do you do for y-intercept? Let x equal to 0. So we got f of 0 equals negative 2 into 0 minus 3 squared plus 2. So maybe 9 is negative 18 is negative 16. Okay, just going to confirm that. So you got negative 2 open brackets 0 minus 3 squared plus 2. It's negative 16. Okay, your turning point. Okay, your turning point is 3 and 2. Okay, so I will do the rest of the calculations and drawings in the next video.